thousands of years ago, in a land far, far away, Greek scientists found something called magnesium. Let's learn about it. We are actually quite lucky here at Central Middle. We have a piece of magnesium. It's this large rock right here. Yes, it's been back in the science lab all this time. And yes, it's magnetic. Our magnesium rock is not very strong. Let's look at some stronger magnets. Okay, let's first talk about the properties of a magnet. Every magnet has a north and a south pole, just like the Earth. In fact, the Earth is a large magnet. Do you have a compass? If you do, go grab it. A compass is basically a suspended magnet. Everywhere it points, it always points to magnetic north. Well, that is Earth's magnetic north. If you take this magnetic north and rub it over your magnet, you'll confuse it. Okay, so magnets can be pretty fun. Okay, here I have a north and a south pole. They are attracted to each other. But what happens if I turn the magnets around and attach north to north? Will they still be magnetically attracted? No, not at all. In fact, I can kind of feel it pushing this magnet away from it. All magnets have a magnetic field. This is the area in which the magnetic is affected, or has effect. Now, if you'll notice, the closer I get to a magnet, this magnetic field is very strong. The closer I get to a magnet, the stronger its magnetic field is. However, the farther I get away from it, the weaker the magnetic field is. Sometimes we'll come across magnets that are no longer effective. This is due to the magnetic domains being scrambled. You see, this north and south no longer attracts. It doesn't work. How can we correct this mistake? Well, one way to correct it is to take a magnet, or even something so simple as a paper clip, and rub it along the magnet that you are trying to correct. The magnetic domains have been scrambled. You need to get them to realign. By doing this process over and over again, you can create a magnet, or at least correct one. If I want to, I can also create a temporary magnet in something as small as a paper clip, but we're not there yet. Sometimes, in order to fix or correct the domains in a magnet, we will use something called a magnetizer. Okay, here's my north, here's my south. We better switch this around. I have two metal bars in each side of the magnetizer, and I'm going to place the magnet right there. Okay, let's turn it on, and now let's begin. Did you see that? I think it worked. It did. Do we want to see it work a second time? Here we go. Can I create a magnet out of a nail? Let's see. I'm going to take these magnets and I'm going to rub them along the nail, trying my best to align the domains. Now, this magnet will not be permanent. It'll be a temporary magnet. This may take a while. And at last, we have our temporary magnet. Okay, it's a weak magnet, but we have one. I'm going to encourage you to go out, explore, and experiment with magnets. But do be careful. If you drop a magnet, The simple action of dropping it could scramble the domains, causing the magnet to become ineffective. Always ask your parents before you use a magnetic around the house. Good luck.